All right, now we're going to do another example, and this one's going to involve finding the domain of a function like these, okay? So here we got our three functions. G of x is equal to 2x, h of x is equal to x squared minus 4x, k of x is equal to the square root of x minus 1. And so what we're going to do is we're going to find these values, right? We're going to not find these values, but perform these operations, right? And then we're going to also give the domain. All right, so g minus x, or excuse me, g minus h of x is going to be 2x minus, so it's g of x, well, let me do it in two steps. So g of x minus h of x, which equals 2x minus x squared, quantity x squared minus 4x, right? Because we're subtracting off h of x, so we want to have parentheses to make sure we distribute the subtraction correctly. So this is going to be 2x minus x squared plus 4x, which is going to give us what? It's going to give us 6x minus x squared. Now, the domain, remember what the domain is for these functions. It's the intersection of the domain of both individual functions. So what is the domain of g of x? That's all real numbers. What is the domain of h of x? That's also all real numbers. So the intersection of these two are going to be the domain of g minus h of x, which in this case is going to be all real numbers. So the domain of g minus h of x is going to be all reals, or in interval notation, we would go negative infinity to positive infinity. All right. Now what about g times k of x? Let's figure out what it looks like, the rule. So we're going to do g of x times k of x, which is going to be equal to g of x, which is 2x, times k of x, which is the square root of x minus 1. So we end up getting this. So it's just going to equal what? 2x root x minus 1. Now let's look at the domain. Now, what's the domain of g of x? It's all real numbers. Okay? What is the domain of k of x? Well, in this case, we have the radical. Remember, we can't have any negatives under the radical. So we want to find the value of where this is 0 or positive. So easy to find where it's 0. Where is this, the radicand 0? When x is equal to 1. Okay? What happens when x is bigger than 1? Well, then this becomes positive. So that means for any values of x that are equal to or bigger or greater than 1, we're okay here. So if we take those two domains, right? The domain of g, which is all real numbers, and the domain of k, which is anything equal to or bigger than 1, we take the intersection of those two, then what happens? We get the interval of 1 to positive infinity. And so we use a bracket here for the open, we use an open bracket because we're including 1 in the domain. Okay? So we're good there. Now, k divided by h of x. Again, we're going to do k of x divided by h of x. And so k of x is the square root of x minus 1, and h of x is x squared minus 4x. Okay? Now, if we look at the domain of both of these, what are we going to get? Well, just like before, this h of x is all real numbers. That's the domain. And k is the domain of everything that's equal to or greater than 1. Okay? So that means if we look at the domain of this function here, right away we know the intersection is going to be what? It's going to be the bracket 1 to positive infinity. Okay? But we still have to look at the denominator, because remember, the denominator cannot be equal to 0. So that's also going to be a restricted value in the domain. So what values make this equal to 0? So let's solve that. Okay? So we have x squared minus 4x is equal to 0. So now, again, going back to factoring, we're going to factor out an x. So that's going to be x times the quantity x minus 4 is equal to 0. And then the zero product principle tells us that x is equal to 0 or x minus 4 is equal to 0. And so that means x is equal to 4. So x equal to 0 and x equal to 4 are restricted. But in this case here, x equal to 0 is not in this domain anyway, so we can ignore that. But 4 is in this domain, so we have to exclude that. So the domain then, we'll have to modify the domain, which means instead of 1 to infinity, we'll have to exclude 4. So we'll go from 1 to 4, right? We use a parenthesis because we're saying not 4. Then we're going to use a union, and then we're going to go from 4, right? Again, we're not including 4, and we're going to go to infinity. So this would be the way we would write the domain in interval notation. All right, and so that's how you do it. All right, practice, ask questions.